Hi everyone. I'm going to start lecture. I'm going to start lecture soon. So, Alright, good afternoon everyone. My name is Steven. I'm our lecturer in sport computing. Today I'm going to present to you visual my way of visualizing algorithms and also virtualizing myself, making a clone of myself on the internet. Okay. Right. So why do I do this thing? This tool of visual. The first reason is because I'm bored. Yeah. I've been teaching the following algorithm classes in SOC since 2005. More to 2010, 2014, 2023, 2024, and so on. From there to now. Yeah. So imagine teaching the same thing again and again for the past decade. Right? So that's why I try to figure out what I usually do when I deliver my algorithm classes. So I started by giving you the motivation of why I use that algorithm. Okay. Like for example, sorting. Right? Then I give them some basic definitions, show them some simple tools, I show them a few examples, then do some analysis, and finally apply the algorithm for myself. Today, I will start with cost and content at the very beginning before starting everything, and at the end, maybe give some research class that I still understand. Then I realized that some of this can be delegated to machines to automate. So, and then before the class and after the class, what usually happens? Nothing. Before the class, the students read how to compare or read the lecture notes beforehand, and after the class, not many people review until the test. Yeah. So what can I do to improve this? So what if I can clone myself and make my future clone available in the internet? So presenting. So if you bring your laptop or iPad, just go to this URL and I will show it to you. So if you go to visual, if you have a handphone, laptops, or iPad, allow you to go ahead. And so in this tool, I have about 20 plus algorithm modules. Each one of them is about 1 or 2 lectures worth in SOC. It ranges from year 1 algorithm class until year 4 algorithm class. So it's the collection of algorithm visualization. And my plan is to make this the website to go for any algorithm class, or every algorithm courses that are available in SOC. If I have time and energy, I will visualize the algorithm. So there are so many options today. So let's just, if you want, let's just go to this lecture called binary search tree. In the second row, leftmost column. Okay. Just click that, and you will be brought up to this page. Okay. Then I'm going to give you a virtual lecture. Okay. So this is the data structure that always covered in year 1 or year 2 algorithm class. So if you're from School of Computing, maybe you still remember this. If you have forgotten about these data structures, let me refresh you. Okay, so a binary search tree is a binary tree. It's a tree where it has at most 2 children, left and right. And then the data are organized in such a way that if you have, I use numbers here, if you have values smaller than current value, I will put those values on the left side of the tree. And if it's larger, it will be always on the right side of the tree. Okay? So when students come to this URL, they will be presented with this kind of introduction slide. And they can press next or press right to see what's the next slide. They can do this before attending the class or after hearing the lectures to review the concept. So this way, the lecture notes is not in PDF or PowerPoint hidden inside an IVLE protected password for people to log in and download the file. It's available online everywhere. You don't have to log in to get this material. Okay. Now, then this tool allows me to show examples that I will normally do in class. In the past, I used that kind of whiteboard to do the same thing. Okay. So this binary search tree, the data are organized in such a way that, let me hide it first. Let me create an even more random example. Maybe this. Okay, this is good enough. Okay, take a look at this number 36. Everything on the left side of 36 are smaller than it. 33 and 5 are smaller than it. Everything on the right side is greater than it. So 81, 60, blah, 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 is all greater. Now let's look at 81. Everything on the left and downwards of 81 are all smaller than it. Everything on the right of 81 are greater than 81. So if we organize the data this way, then we can do search on this data structure in an efficient manner. So I will usually ask the student in class to throw me any random number between 1 to 99, and I will show you how I can quickly find whether that number exists or not exists in this data structure. So maybe you can give me any random number 1 to 99. 99. Okay, so I'm going to search for 99. So this is to show people that I'm not scripting any of this. Okay, so if I organize the data as shown in this picture, I will have to start from the root or the topmost element, and I compare 99 with it. 99 is not 36, right? So if I already organize the data in such a way that everything on my left of 39 will be smaller than it, should I go to the left side? No, I should go to the right. Okay, so I now at 81, and I repeat the same questions. I want to look for 99. Knowing that the data is structured in such a way that everything on the left side of 81 are smaller than 81, if I'm looking for 99, it should be on the right, right? If it exists. I keep doing this. And I conclude that 99 does not exist, because after 88, I want to look for the right side of 88, nothing there. So 99 is not in this binary search tree. Okay? So student can repeat these questions, this example, many times on any numbers up to their liking. They can search for any numbers, existing or non-existing number. Let's look for existing number, maybe 39. 39 exists, right? So usually I will show them that I understand the concept by showing the part will be 36, 81, 60, 39 found. And then they can see that the system is really doing the same thing, so they can believe that I understand the thing. Yeah, and they can try creating any random test cases and do another theories on their own. They do this until they understand the concept by themselves. Compare this with traditional lecture notes where there is only 1 or 2 scripted example inside a PDF, which is you cannot edit. So student can only review that same example forever until exam. Then when we test them with different numbers or different test case, they fail because they don't really understand the concept. Here, they can repeat until they understand. Right? Then another thing that I want to show it to you that is on the top left is ability to change language. So I'm going to show the Indonesian version of the same page. Not everything has been translated, but some of them already. So look at the menu here. It changed from English to Indonesian. So if I am an Indonesian, I don't understand English, I can go to the same page and understand the concept, because cari is search. Search for number 7. Lakukan means go, do. So cari di kiri, go to left, go to left, go to left, go to left. 7 is not in this menu system. 7 to do tidak ada di sini. Yeah. So This is the visualization side of visual. Right? Now, before I forget, I want you to try doing something that most other students, students nowadays frequently do when they don't understand what their lecturers are doing, teaching them. They go to Google, right? Suppose they don't understand about algorithm. Right? Then they will probably search this kind of questions and look who is number one. Okay? So suppose I want to learn about sorting animation, or sorting visualization. Having a very good high search ranking will increase the visitor rate from many other CS students worldwide, not just from school of computing. And that's what I'm experiencing at the moment. Okay, so let's continue. But that's not the only part of this tool is not just about visualizing algorithms. There is another second part of the tool that I'm going to highlight to you now. Okay, in NUS and many other universities, after lectures, there are smaller tutorial class or laboratory classes where we discuss more in-depth questions about the topic. Right? So in NUS, there is 11 weeks, 1 hour each to do those tutorials. Usually, we discuss 3 to 5 questions per week. But what if I can clone myself 24/7? Then these students can access questions that I have prepared for them, 100 at the moment, 100 plus, and they can review until they understand. Okay, and then I can hide some of the harder questions and use it for assessment. Let's look at the demo of this online quiz portion of the tool. So this online quiz portion of Quizolvo is about algorithm questions, but the questions are randomized. There are parameters that I randomize in the questions because I don't like the questions to be static. If it's static, then the answers can be memorized. So I cannot differentiate whether the student understand or they memorize the answers. So I built a tool to generate algorithmic questions with randomized parameters and like random graph, random numbers, random starting point, something like that, and let the students submit their thing and submit their answer within a certain time frame, and then I give them instant grading. There's nothing beats instant. Nothing beats instant. So a human grader will take days or weeks to grade an exam, but the computer can do this in seconds. And then if they got wrong answers, you can give feedback. Currently, the tool gives generic feedback, but after hearing the talk from other colleagues, maybe I want to personalize some of them. Okay, so let's look at the direct example. Okay, so let's skip this one. Let's just do a real demo. So if you go again to the main page, there is a training button here, or if you see the module, there is a training button. Let's click that one. Right? Then you'll be presented with this online quiz. The default setting is I like number 7 because my name is Steven7. So 7 random questions. Okay. If you refresh, currently number 1 is this true or false, the smallest element, blah blah blah. Okay. So if I just refresh this, you will see another 7 random questions. Right? So nothing is scripted. Okay. So this is binary search tree. What's the maximum element in the binary search tree? Okay. Suppose if you don't really understand binary search tree, you will probably eyeball this and verify that among these 3 numbers, 72 is largest. But on harder task case, the picture will be much bigger. So you need to quickly identify using some rules. And suppose I do a wrong answers. This is the largest is 72, right? I click wrong. Right? And then let's look at the search. Just now I teach about search, right? So how to go from root to find 77. Suppose I do it wrongly. I go like this. Okay. Let's do wrong. I stop at 99. So I go 14, 30, 99. I haven't clicked 77. So this is wrong. So I have, out of 7 questions, I answered 2 and 2 are wrong. Let me select one that is correct. Maybe this one I select that is correct. So 1 correct, 1 wrong. Let me submit. in less than few seconds, in milliseconds, I got the feedback, 1 out of 7 correct. So for these questions, what's the maximum? I correctly select 72, right? And this 5, I don't answer. But this 7, and question number 7, I go from 14, 30, 99, and I stop. The correct answer is 14, 30, 99, and 77. And then, if a student doesn't understand what's happening, he can click this link to view. Okay. To view, the link is a bit incorrect. Okay. Let me redo this. The link is going to be fixed later. Okay. Students can recreate the same BSD, the same structure, and then they repeat the same animation. So they got wrong answers, they can repeat the example and have the tool re-explain what should actually be the correct answer. Okay. So this has helped me a lot. This has helped me a lot in running my courses. Okay. So currently it has about 3,000 daily visitors. Not just during NUS semester time, but there are many other universities using this. I haven't really counted, but it's nearing hundreds. Different universities have using this. I have the data, but again, I have not analyzed it. It's just there, being done in the database. And then it appears in top 10 or maybe in second page in Google search for many related keywords. So there are many new visitors because they stumble upon this tool after they Google term. Right? And it has helped me do better in my academic classes. But of course, there are things that I can improve. Currently, the online quiz tool or Visual can only ask basic questions. Cannot suddenly come up with a new final exam question. Cannot. Okay? And then, because the question bank is available online, it's 24/7. Some diligent students can, of course, practice like crazy until they master it, which is the intention of the tool. So they can get near full marks in the actual exam. Okay? So I need to hide some of the harder questions and only show them during tests. Okay? So the current tool is not for final exam level, but it's good for training. They have to train them in basic stuff. And this is from last year's. I do an analysis of what's the difference between the online test and the written test that I did a few days later on the same group of 150 students. They trained like crazy, so almost everybody got everything correct except these two questions, question 4 and question 17. I will show you what's question 4. But on normal tests, the average is about 70, 80. So it's not that almost everybody get 100. Because in the actual final exam, when I put in creative questions, then it separates me. So the questions number 4, that only 40% got it correct. It's about shortest path. What's the shortest path from vertex 0 to every other vertices? Click those that are greater than 18 values. Most people click 4 because of 17 plus 13 is 30. Right? It's greater than 18. So most people click 4. But this is hard because there is a presence of negative numbers. So the correct answer is 17 minus 7 minus 41 plus 39. This is less than 18. So you should not click this. So many people got careless mistakes. So the feedback is they don't like to be tested this way because they lose marks because of careless mistake. So currently the system is hiding some of the hard questions from their training mode, so that they train like crazy on the easy, medium questions, but on the test I show them some of the challenging questions, so that I can use the tool to differentiate the groups of people. Otherwise, they will train until perfection. I cannot use this to differentiate. I can only use this for making sure that they understand the basics. Okay. And so these are the current version of Visual. It has been available for 6 years in 2011. So some of the tools that features that I want to add is after learning the session from yesterday, how can I give more personalized guidance so they can log in and follow a learning pathway, and I can give individualized feedback on them. And then, of course, if you change the languages, you will see that although you selected Chinese, for example, text still in English. The system is ready. I just need a proper translator to do this. Okay. Then I still have ideas to visualize some other algorithm classes that I haven't visualized. I want to do that. And then, of course, increase the number of questions in the Parliamentary bank. Okay. That's the end. Thank you.